Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of derivatives. So as per the problem, for f at x equals x cubed minus kx, where k belongs to the set of real numbers, find the values of k such that f has no critical numbers, one critical number, and two critical numbers. So the first step is to understand what is a critical number. So a critical number is the x coordinate of a point where the derivative of the function is equal to 0 or undefined. Now this function is a polynomial function. So for no x value, this function will be undefined. So we just have to find the x values or the critical numbers that will make the derivative of this function equal to 0. So the first step here is to find the derivative of this function. So prime of f at x equals, now the first term is x cubed. Now the derivative of x cubed can be found using the power rule. So we should move the exponent to the front and then we subtract 1 from 3. Now minus, now k is a constant because it's a real number, so it will stay as it is, and the derivative of x is equal to 1. So k is the coefficient of this term, so that's why it doesn't change. Now we can simplify this expression. So prime of f of x equals, so we get 3x squared minus k. Now we have to find the x values that will make the derivative equal to 0. So we sub in left side as 0 and we get 3x squared minus k. Now we have to solve for x. So we have to isolate x. So the first step is to add k to both sides. So the k's on the right side get cancelled out. So we get k equals 3x squared. Now we can divide both sides by 3. So the 3's on the right side get cancelled out. So we get x squared equals k over 3. And now we can apply square root to both sides. So on the left side, the square root and the square cancel each other out. So we get x equals plus minus square root of k over 3. Now let's analyze part A, no critical numbers. Now we have to find the values of k such that this function has no critical numbers. Now we got the expression for x as plus minus square root of k over 3. Now if k is a negative number, then x will not be any real number because square root of a negative number does not exist or is not a real number. So that means we will not get a real value for x if k is a negative number. So that means, so this function f will have no critical numbers if k is less than 0. So there is a very important concept we need to understand to solve this type of problem. So let's analyze part B. So the function should have one critical number. Now the expression that we got for x is equal to plus minus square root of k over 3. So we have two cases, the plus and the minus. Now we want just one critical number, and we'll get one critical number if k is equal to 0, because 0 does not have a plus or a minus sign. 0 is just 0. So that means we'll get one critical number for this function if k is equal to 0, because then the value of x will just be 0. So now we can analyze part C. So the function should have two critical numbers. Now for that, if the k value is greater than 0, a positive number, then we'll have two x values, one with a plus sign and the other one with the negative sign. So the k values that will give us two critical numbers are k is greater than 0. So this should be the final answer for this problem. So these are the steps you have to keep in mind to solve a problem like this one. So here we found the expression for x, the critical number, and we realize that there are two possible cases, plus and minus. So we have to then analyze the k value accordingly so that we are able to get no critical number, one critical number, and two critical numbers. So these are the steps you have to keep in mind to solve this type of problem. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.